This is our first, I guess technically second, official day of mixing all the exponents together. We've covered them all. So let's break it down. Really, whenever we're seeing a problem, think like PEMDAS. We have to follow a certain order of things. The first one is look for any power rule. That's whenever there's an exponent outside the parentheses that needs to be distributed inside the parentheses. Then we look for product rule, which means if you see parentheses times parentheses or that little dot, you multiply your coefficients, add your exponents. Quotient rule is when you see like a fraction, looks like division, but it's a fraction form. You simplify your coefficients and subtract your exponents. Now, these two are what I call the floater rules, your negative exponent and your zero rule. The negative exponent is more or less something you check for as you work through the problem and normally towards the end, because your answer cannot have a negative exponent. If it does, in order to make it a positive, you move its location. So if it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. And then the floater one that I call is the zero rule. This is anytime your variable cancels, essentially, is whenever you add or subtract the same exponent or you're subtracting the exponent on quotient rule. Those are just kind of, they happen throughout the problem. And then lastly, you add and subtract if and only if they have the same last name. So let's jump right in. If I look at number 1, let's go down the list. Do you see power rule? Do you see a number outside the exponent or outside the parentheses that needs to be distributed? Yes, but it only applies to the denominator. So I'm just going to copy and paste the numerator. Well, when I distribute this 2, it's not 4 times 2, it's 4 squared. And 4 squared is 16. When I distribute that 2, how many x's do you end up with? Well, 2, because 1 times 2. How many y's would you end up with? Also 2. And then, do you have product rule? No. Do you have quotient rule? Yes. 12 over 16, do not divide, you simplify. 12 over 16 simplifies to 3/4. I subtract my exponents, so 9 minus 2 is 7, and 4 minus 2 is 2 for the y. And the last thing you want to check is, do you have any negative exponents? And I don't, so this is my answer. Now I want to specify how else this could be written. You could see it like this, which is great, or you could see this x to the 7th and y squared in the numerator with the 3, because I wouldn't have needed to move it to the denominator, and you'll see 4 at the bottom. So just be prepared to see it either way. If I look at number 2, power rule first. So I'm going to distribute the 4. 2 to the, it's not 2 times 4, it's 2 to the 4th power, and then 2 to the 4th power is 16. How many x's would you have? Well, 1 times 4 is 4. How many y's would you have? 4 times 4 is 16. And then you distribute the 2 in the denominator because it's also power rule. 2 squared is 4. X would be 4 and y would be 6 because 2 times 2, 3 times 2. Do you have product? No. Do you have a quotient? Yes. Simplify. What's 16 over 4? That equals 4. Notice here is why it's called a floater, because x over 4 over x over 4, it essentially divides out to x equals 0 when you do the quotient rule, but x to the 0 power is just 1, which I sometimes just say it cancels out. So no x, and then y is 10 because 16 minus 6. So far, so good. Number 3, anytime you see a power or exponent outside the parentheses, it applies to everything inside the parentheses. So I'm going to distribute this 2 to the numerator and the denominator. So 12 squared is 144. X would be 10 because 5 times 2. 15 squared would be 225, and then it would be x squared because 1 times 2. And 144 over 225 is, excuse me. Remember, you don't want to divide it out, so you type it in as a fraction to triple check your work. And that equals 16 over 25. And your x's would be 8 because 10 minus 2. Now this is okay to write, but you could also see it written 16x to the 8th over 25. So you'll see the x to the 8th in the numerator. I'm going to skip to number 5 because number 4 is just like number 3. But let's go down the list, okay? If I do power first, is there anywhere in the problem where you see an exponent outside the parentheses? You don't. Well, next step is product. Do you see any multiplication? And that does apply to the numerator. 9 times 4 is 36. If I add my exponents, x would be 6 and y would be 7. Since that's the only product remaining, I'm going to bring down the 6x squared y to the 4th. And then I'm left with quotient rule. 36 over 6 is 6. And quotient rule says I subtract my exponents, so x would be to the 4th power and y would be to the 3rd power. And since there's nothing left, that's my answer. If I look at number 6, power rule first, so I'm going to distribute the 2. 10 squared is 100. A would be 2, B would be 2. Now, since that's the only power within the problem, I'm going to copy and paste. The more organized you are, the better. And bring down everything else. Because then I do product rule next. 100 times 2 is 200. I add my exponent, so A would be 6, B would be 5, and then over 4A to the 5th B. Then I'm left with quotient rule. 200 over 4 is 50. A would be 1 and B would be 4. And there it is. If I look at number 7, and actually, if I'm not mistaken, some of these are the same questions that we did on yesterday's notes. So I'm going to skip to the back. If I look at number 9, okay, notice the only rule here is product rule. So I just treat it like a problem, product rule problem. 2 times 5 is 10. When I add my exponents, x, -4 plus 5 is +1, and y, 1 plus 5 is 6. So even though there was a negative exponent in the problem itself, the product rule took care of it. It's only when I get to my final answer that I want to worry about the negative and fix it, but this one didn't have that. If I look at number 10, there is no power rule. There is product, though, in the denominator. So I'm going to copy and paste the numerator. And then we're going to multiply the coefficients, 3 times 2, which is 6. I would have 5 x's because 4 plus 1, and I would have 2 y's. Now it's just quotient rule. 4 over 6 simplifies to 2/3. Now this is where I have to be careful. Because notice the x and the only x that's there is in the denominator. So it stays there. And then the y's would be 3 minus 2, which is 1. And so I'm just going to leave it in the numerator with the 2, because that's where it was originally. And there's your answer. If I look at number 11, I do see power rule. So I'm going to distribute the 0 first and bring down the y squared. But let's talk about it. 2 to the 0 power we talked about is called our 0 rule. 2 to the 0 power is just 1. So what is x -3 times 0? Also 0, which equals 1. 0 times 0, also 0. So this part actually zeroes out in a way after I did the distributing. Now then I do 2 to the -3rd power. So I'm going to copy the product rule. 2 to the -3rd power. We'll fix that in a minute. And then x would be -2 times -3, which is +6. Now, the issue with my answer is a couple of things. First, the negative exponent. So let's take care of that first. Notice that 2 to the -3rd is the only negative exponent. So x and y stay in the numerator. And I'm actually going to switch places because it technically should be alphabetical. And then to make 2 to the -3 a positive exponent, I'm just going to move it to the denominator underneath the x and the y. Now, because it's 2 to the 3rd, this is the last thing I need to fix. I don't leave it 2 to the 3rd power. I simplify it. 2 to the 3rd power is 8. And that is your answer. Number 12, there's no power rule. There is product, so I'm going to copy and paste the numerator and do the product rule. 2 times 2 is 4. I would have -2 plus -1 is x to the -3rd. -1 plus -1 is y to the -2nd. And then I do the quotient rule. 3 over 4 does not simplify past 3 over 4. When I subtract my exponents, this is where you have to be careful. 2 minus -3. Think of that again. 2 minus -3 is actually adding 3, so it's x to the 5th power. -1 minus -2 is like saying -1 plus 2, so y ends up being +1. Now, because my answer doesn't have any negative exponents remaining, it took care of itself. I'm done. If I look at number 13, we have the power rule first. So I'm going to bring down the x squared, y cubed, and the multiplication. So this would be y to the -4th power because -2 times 2. Then it's the product rule. Now, since there's no more x's, it's just bring down that x squared. And 3 plus -4 is -1. But the issue with my answer is I cannot have a negative exponent. So x squared is going to remain in the numerator, and I'm going to bring down the y to make it positive, and y to the first power. If I look at number 14, I'm going to distribute that -1 first. So this is 2 to the -1 power. X would be -2 because 2 times -1, and y would be -3 because 3 times -1. Times, I distribute the 4, it would be y to the -16th power. Now, technically we do multiplication first. Now 2 to the -1, we're just going to leave 2 to the -1 for now and fix it in a second. I add my exponents, but since x is the only -2, I'm going to bring it down. And when I add -3 plus -16, I have -19. Now the issue with my answer is all of the exponents are negative, so I have to make them all positive. Now since they all need to be moved to the denominator, what do I leave in the numerator? You leave a 1. And so then 2 is +1, x is +2, and y is +19. Now normally I would have to clean up 2 to the first power, but 2 to the first power is just 1. If I look at number 15, power first. So I'm going to bring down the rest of this, y to the third times 2x to the third, y to the -4th, times whatever this is. So when I distribute that -3, x is -12, y is +12, and then I do the product rule. Well, the only number in front of the variables is 2, so just 2 times 1 is just 2. If I add my x's, 3 plus -12 is -9. And if I add my y's, 3 plus -4 is -1. -1 plus 12 is +11. And the only issue with my answer is the exponent that has a -9. So the 2y to the 11th remains in the numerator, and x to the 9th moves to the denominator in order to make it positive. Number 16, there is no power rule, but there is product. So 2 times 3 is 6. When I add my x's, 1 plus 0 is just 1, and -2 plus 4 is +2. I bring down the denominator, and then I look at what's remaining. Quotient rule. 6 divided by 2 is 3. Technically, when I subtract my exponents, x to the first power minus 0 is just x, and then 2 minus 4 is -2. The issue with that answer, though, is the negative exponent. So I need to make it positive, which means 3x remains in the numerator, and then y squared moves to the denominator. Number 17, anytime you see that exponent outside the parentheses, it goes to everything inside the parentheses. So this isn't 2 times 3, it's 2 to the third power. X would be 6 because 2 times 3. Y would be -12. I also do the same thing for the denominator. X would be -9. Y would be +9. Z would be 9. Then I'd multiply times 2 to the third, so 2 to the third power. X would be 3, and Z would be -6. Now, what's next? Before I can do quotient rule, I got to do product rule. So look at the denominator. I'm going to copy and paste. This one should have probably left more room, sorry. I'm going to copy and paste the numerator and clean up the denominator. 1 times 2 to the third is just 2 to the third. X is -9 plus 3, which is -6. And then y is 9, because it's the only one. Z is 9 plus -6, which is 3. Now I'm left with the quotient rule. Well, 2 to the third, if I've cleaned that up, is 8, and 8 over 8 is just 1. So those essentially cancel out. The x's also cancel because x to the 6 over x to the 6. But when I look at my y's, be careful. What's -12 minus 9? Well, that's y to the -21st power. And then I look at the z's, and notice where the z, there's only one z there. It's in the denominator. So it needs to remain in the denominator until otherwise specified. Now, that being said, the issue with my answer is the negative exponent. Well, the y is -21, and to make it a positive, I need to move it down to the denominator. But if I move it down to the denominator and I have nothing remaining in the numerator, you have to put a 1. So it's 1 over y to the 21st power, z to the third. So that one's a little tricky. If you look at number 18, distribute the 5 first. So 2 to the 5th power is 32. X would be 15, Y would be 20. I have another power rule here first, but product goes between them. So 3 squared is 9, X is 4, and Y is 14. And I copy and paste the denominator. And then I do the product rule. 32 times 9, oops, good thing you can see that, is 288. X's would be 15 plus 4, which is 19. Y's would be 20 plus 14, which is 34. Bring down your denominator. 288 over 6 is 48. If I subtract my exponents, X is 14, Y is, sorry, I'm not braining today, Y is 19. And since I've already, I don't have any negative exponents, I continue on. So if I look at number 19, there is no power rule, but there is product in the denominator. So I'm going to bring down the numerator. Product rule, 2 times 1 is 2. V, when I add the exponents, is negative 3 plus 6, which is 3. And W, 2 plus 1 is 3. Then I do the quotient rule. 8 over 2 is 4. When I do V, 5 minus 3 is 2. And W, negative 6 minus 3 is negative 9. The only issue with my answer is that negative exponent. So I'm going to move it to the denominator while V squared stays in the numerator. W becomes 9, and the positive 9 in the denominator. Number 20, distribute the 5. 6 to the 5th power is 7,776. X is negative 15. Y is positive 25. Then 2 to the 5th power is 32. X to the 5th, Y to the 10th, Z to the 30th. And then I do the quotient rule. 7,776 divided by 32 is 243. X, be careful here, negative 15 minus 5 is negative 20. Y, 25 minus 10 is 15. And Z, actually, since there's not a Z in the numerator, Z needs to remain in the denominator until we fix anything. Then we look at our answer. The only issue with my answer is that negative exponent in the numerator. To make it positive, I'm going to move it down to the denominator. So 243, Y to the 15th remains in the numerator. X to the 20th and Z to the 30th remains in the denominator like that.